Since the dawn of civilization, we have gazed at the stars and wondered, are we truly alone? Music, billions of suns blaze across our galaxy, each offering the possibility of alien worlds teeming with life. Yet, when we look up at the night sky for signals, we are met with silence. This begs a question. Is life extremely rare or just hard to detect? I'm always interested in questions where there's a collision of ideas that appear irreconcilable, right? They don't fit with each other. And I think that collision of ideas in cosmology is very vivid when you bring it together with biology, which is that we are physically insignificant. But it is possible to argue that we are remarkably valuable, notwithstanding our physical insignificance, because it's possible to at least argue that the number of civilizations in a galaxy like the Milky Way might be, on average, one or less. Our galaxy, the Milky Way, is estimated to contain between 100 and 400 billion stars, and at least as many planets. A new study suggests there could be 60 billion planets in our galaxy's habitable zones, regions capable of supporting life. For a planet to support life as we know it, it must have liquid water, energy, and nutrients. These basic ingredients appear to be common throughout the universe, but we have yet to find evidence of other civilizations. So where is everybody? Well, it's the Fermi Paradox. The Fermi Paradox, going back to the great physicist Enrico Fermi, is essentially the question, where are they? You base it on the observation that there are somewhere between 200 and 400 billion suns in the Milky Way, something like that. We think a lot of them have planets. Many of them have potentially Earth-like planets. So you have 13 billion years of time, hundreds of billions of suns, probably trillions of planets. And so is a reasonable question to ask, why not? Why has a civilization not arisen ahead of us, say, a billion years before us? Why has no civilization escaped its home world, apparently, and essentially written its existence across the sky? Why is that? Why don't we see anybody? One of the arguments is often framed in terms of self-replicating machines, so-called von Neumann machines, named after the great mathematician John von Neumann. Essentially, the idea is, what are we? What's a human being? It's a replicator, right? It's a physical object. It operates according to the laws of physics. That's what we do, we replicate. So, it seems that there's no reason why we couldn't build replicators that are essentially AIs. Basically, an AI-controlled 3D printer with some mining equipment attached to it. You send it off to the asteroids or Mars or Alpha Centauri, where all the raw materials exist to allow this thing to replicate. People have modeled how those replicators might spread throughout a galaxy. There's a great book I would recommend by John Barrow and Frank Tipler called The Anthropic Cosmological Principle. It's a very famous book, and it had a huge influence on me. In that book, they present a series of calculations estimating how long it would take for self-replicating machines to spread throughout a galaxy, given some reasonable technological assumptions. If someone had built such a machine even a few 100 million years ago, these machines would be everywhere by now. It's like a virus. It propagates exponentially. The whole galaxy would. So, you might say that's evidence that nobody ever did it. Or, in the spirit of being scientific, we might think maybe they're just too small to detect, perhaps the size of a phone? Maybe they are so advanced that they're already in our solar system, and we don't recognize them? You can argue about the Fermi Paradox, but broadly speaking, it is the observation that, despite all our astronomical observations, we have never seen evidence of anyone else. And that's the paradox. Because with so much time and so many planets, it seems like somebody should have left a trace. The Fermi Paradox often considers that advanced civilizations might not last long enough to be easily detectable. They may be transient on a cosmic scale, meaning they arise and then disappear due to factors like self-destruction or natural catastrophes. Researchers argue that if technological civilizations routinely self-destruct or otherwise burn out, then the chances of overlapping with our own window of detectability become very small. This short lifespan would explain why we don't see evidence of them today. Carl Sagan famously said, "It's possible that civilizations don't get beyond the stage that we're at." When a civilization industrializes, it faces challenges common to all civilizations due to the laws of physics. One of these is the impact of industrialization on the planet's climate. As a civilization grows, It consumes resources, alters the atmosphere, and must learn to manage these effects. Another challenge is the development of nuclear weapons. Any civilization advancing toward interstellar travel would likely develop nuclear physics, meaning it gains the capability to destroy itself. It may be that these challenges are just too difficult to navigate. This idea is part of what is known as the Great Filter. So we ask, is the Great Filter in our past? Perhaps the most difficult step was for life to evolve from single-celled organisms to multicellular life. That does seem difficult, based on Earth's history. If so, then we have already passed the Great Filter and should be relieved. Or, is the Great Filter in our future? It could be that nuclear war, climate catastrophe, or some other unknown factor prevents civilizations from advancing. If that's the case, then we may be approaching the filter, and we might not pass through it. Many people in the general public believe the Fermi Paradox needs no solution, as they are convinced that aliens have already visited us. However, in science, extraordinary claims require extraordinary evidence. One related idea is the zoo hypothesis, which suggests that advanced extraterrestrial civilizations exist but intentionally avoid interacting with us, like zookeepers observing animals. While this is possible, one could argue that zookeepers don't hide from the animals. If this were true, these aliens would have to be very good at staying undetected, constantly adapting to our growing detection capabilities. Recent estimates using the Drake equation suggest that the Milky Way may host very few detectable civilizations, potentially only one, the human race. While earlier estimates were much more optimistic, this updated perspective considers the possibility that civilizations may not last long enough to become spacefaring. But we don't know the answer. How many worlds in the Milky Way support life? We don't know. We only know of one, ours. Most scientists suspect that life is likely to exist elsewhere, but we currently lack concrete evidence. Until we have more data, we should act as if we are alone. If detectable civilizations are rare, perhaps because most self-destruct, then we must be vigilant in safeguarding our own survival. If we fail, we may extinguish the only known instance of conscious life in the Milky Way. Carl Sagan once argued that if a civilization survives long enough to become interstellar, it must learn to cooperate rather than destroy itself. He suggested that violent civilizations don't reach the stars because they cannot overcome the problems necessary to build interstellar spacecraft. Whether he was right or not remains to be seen. Ultimately, the power of the Fermi Paradox.